This is the lecture after significant figures. This is going to be doing math with significant figures. So before we get into doing math with significant figures, we're going to do a bit of a review of how we determine the amount of significant figures in any measurement. Rule number 1 is all non-zero digits are significant. By those I mean numbers 1 through 9. Rule number 2, all zeros between non-zero numbers are significant. For example, the number 302 has 3 significant figures. Rule number 3, all leading zeros are not significant. This means any zeros that come before non-zeros are not significant. Lastly, rule number 4, trailing zeros are significant only when there's a decimal point. So the number 8,000 has 1 significant figure. 8,000 with a decimal point has 4. All right, why is it different? Significant figures measure our accuracy in a measurement. If 2 different measurements have different accuracies, we need to account for that. Think of the graduated cylinder and the beaker. If you measure out liquid with both of those tools, you are going to get a different degree of accuracy. Having different accuracies refers to the amount of significant figures in the measurements or numbers. This also means we have to round our calculator answers using one of 2 different rules. Today we're going to work with numbers that have no units. All right, rounding rules. If the next number is 4 or less, you're going to round the number down. For example, you're going to round 43.22 to the nearest tenths, and you're going to get 43.2. If you have to round 5,482 to the tenths, then you're going to end up with 5,480. If the next number is 5 or more, you're going to round the number up. For example, you're going to round 12.37 to tenths and get 12.4. Or if we round 5,470 to the nearest hundredths place, we would get 5,500. Very well. So now we are going to get into the doing math with significant figures rules. After adding or subtracting numbers normally, you will round the final answer to the last place value both numbers share. Here's an example. The numbers 12.1 and 45.22 both have numbers in the tenths place, but not the hundredths place. So the answer would be rounded to 1 decimal point, or the tenths place. Here's an example. 5.43 plus 7.4. Your calculator answer is 12.83. However, both quantities have only the tenths place, so you have to round that calculator answer to 12.8. Here's another example, 62.43 minus 53.8. The calculator answer is 8.63 milligrams. Our rounded answer becomes 8.6. Here's another example, 4.33 plus 5.344 plus 4.3. Our calculator answer is 13.974. We round that answer to 14.0. With multiplying and dividing, we have a different set of rules. After multiplying or dividing normally, you will round the final answer to the same number of significant figures as the lowest amount of significant figures from the starting numbers. Here's the example. The number 12.1 has 3 significant figures, while the number 43.22 has 4 significant figures. If you multiply them, the final answer would be rounded to 3 significant figures. So in this case, when you multiply or divide, you're looking at the total number of significant figures. With adding or subtracting, you are only looking at the places after the decimal. Let's continue. Here's an example. 5.44 times 4.2. My calculator answer is 22.848 grams squared. 4.2 only has 2 significant figures. 5.44 has 3 significant figures. So my final answer is going to be 23. Here's another example. 6.33 divided by 2.444. My calculator answer is 2.5900163666. The rounded answer is 2.59. Another example, 5.46 times 4.235 times 1.2. The calculator answer is 27.74772. My rounded answer is 28.